Hey, so in this video, we're going to be looking at the basic trigonomic ratios in a right angled triangle. Now, this is the absolute basis of trigonometry, in which you guys will learn how to use these ratios, and from then on, we can move on to more complicated trigonomic problems. So before we begin, trigonometry is a study between the relationship between angles and side lengths in a triangle. So trigonomic ratios, the one we're looking at right now, SOHCAHTOA, which stands for something, it refers to the ratios used in a right angle triangle. A right angle triangle meaning a triangle with a 90-degree angle in one of the side lengths. So the first relationship we're going to be looking at is the sine ratio, which states that the sine of the angle equals the opposite over the hypotenuse. And this is referring to the side length, or the value of the side lengths. And remember, this angle right here is always, this angle or the sides opposite over hypotenuse is in reference to this angle of study. So in this diagram, this angle, the opposite side would be opposite rate of the angle over its hypotenuse, which is hypotenuse is the longest side. So hypotenuse stays the same, which is right here. Opposite over hypotenuse. So this is the first trigonomic ratio. Sine of the angle equals opposite over hypotenuse. And now as you see, is the sine equals opposite over hypotenuse, we have written as so. So this is how we're going to memorize these ratios. So SOHCAHTOA, which the first stands for sine over equals opposite over hypotenuse. Now let's look at the second trigonomic ratio, which is cosine. So the second trigonomic ratio states that cos of the angle equals adjacent over hypotenuse. Again, we are looking in reference to the angle of study, which is right here. So adjacent, which is right here, the adjacent side, over the hypotenuse, which is, again, stays the same. And this is C equals A over H, or rather cos of the angle equals adjacent over hypotenuse. And lastly, we're going to be looking at the TOA part, which is tangent. So we know that tan of the angle is written as opposite over adjacent. Opposite meaning this side right here, and adjacent meaning this side right here. Again, all in reference to the angle in study. So these are the three basic trigonometric ratios in which we will build our basis for further study. Okay, let's go straight into the example. So in this diagram, which is a right angle triangle, we can see that we have some sources of information. The first information we have is that this angle right here is 30 degrees, and the hypotenuse, or the longest side, is 15 meters. And we know that it is a right angle triangle since this box declares it to be 90 degrees. So let's first figure out what we don't have. We don't have the side length x or y, and we want to figure out these side lengths. So how will we go about doing this? The first thing we have to do is look at which sine ratio we have, which trigonomic ratio we have to use that can help satisfy the demands of this problem. So we know we have our hypotenuse. So sine and cosine both have the hypotenuse sine, and we know that we don't have our x or y. And since it's always referenced to the angle of study, the x would now be the adjacent side, and the y would be the opposite side, because you're going opposite from the 30 right here, and this is adjacent. So remember, always in reference to the angle. So to figure out x, we know that x is our adjacent side, and the only ratio that can help us satisfy and solve this problem will be the cos angle identity. So cos of the angle, or rather cos of 30, equals the adjacent side, which is our x value, over our hypotenuse, which is 15. Now to solve this, we have to use our basic algebra skills to isolate for x, in which all we have to do is bring 15 over to the other side by timesing both sides, which makes it 15 cos 30 equals x. Now this is an exact answer. If we plug it into our calculator, we should get about 13 meters roughly. It's actually 12.99, but 13 meters is close enough. So this is the first example of the use of the trigonomic ratios. Now let's figure out how to find for the y. This is the opposite side, so therefore we have to use an equation which has both the hypotenuse and the opposite side, which is the sine equation. So sine of the angle, or rather sine of 30, because it is the angle at study here, equals opposite, which is y, over the hypotenuse, which is 15. So bring 15 over to the side, makes it 15 sine 30 equals y, in which we put into our calculator, should give us 7.5. Okay, now let's look at another example in which we're now solving for the angle. So looking from the diagram, what pieces of information do we have at our disposal? We know that we have the side length 15 and we have the hypotenuse as 25. Remember, since we're solving for the angle, 15 will be the opposite side, and 25, since it is the longest side, will have to be the hypotenuse. Now, from these sources of information, we have to look at our equations, or rather our trigonomic ratios, that which one will satisfy our demand. We know we have our hypotenuse and we know we have our opposite side. So we have to look at which one has hypotenuse and opposite in the equation. It cannot be tan because it requires a knowledge of the adjacent side right here, which we do not have. Same with the cos. So our only option here is to use the sine. We know that sine of the angle is equal to the opposite side over the hypotenuse side. The opposite side being 15 and the hypotenuse being 25. But the thing is, we are solving for the angle. So the angle will have to equal sine inverse times 15 over 25. Now this sine inverse equals 1 over sine. Now to actually carry about this operation, you would have to go into your calculator and put this function or this operation in. And to do that, most calculators will have the sine inverse, the cos inverse, or the tan inverse as a secondary function. So you would have to use your calculator to carry about this operation. So when carrying about this operation, you should get the angle equaling 36.87 degrees. So this is a use of this ratio when solving for the angle. Let's have one final example to wrap up the concepts learned in this video. So in this example, we have to solve for all the angles, which is just 1, and all the side lengths, which is x and y. Let's start with solving for y. So when solving for y, which is a side length, we have to look at what pieces of information do we have. We know that we have an angle, which is 15 degrees, and we have a side length, which is adjacent to that angle, which is 9 meters. So, knowing that we have an angle and a side adjacent, we are searching now for the side opposite of the angle given. So opposite of the angle given would be y. The only ratio that can help us solve this would be tan, because we're solving for the opposite side, we are given the adjacent side, and we have the angle. So we can solve for the opposite. So tan of the angle, or rather tan of 15, equals the opposite side, which is y, over the adjacent side, which is 9. So y will equal, or the side length y will equal 9 times tan of 15. Doing this in your calculator, we should get 2.41 meters. So that is solved. Now let's move on. Having solved for y, which is 2.41, we can move on to finding out either the side length x or the angle a. Let's find the side length x right here. So in reference to the angle given, we know that side length x has to be the hypotenuse, because this is the adjacent and this is the opposite. And more than likely, the hypotenuse is always opposite to the 90-degree angle. So x would have to is our hypotenuse side. So now we know that we're searching for our hypotenuse. So the information we have at our disposal is that we have the angle 15, adjacent to that is 9 meters, and opposite to that is 2.41 meters. Now, just advice that when solving for multiple unknowns in a given question, always try to avoid the calculated values, or the values that you have to calculate in order to find. Y would be an example of this. So let's try to solve this without using y. And the only the ratio that can help us solve this will be the cos equation, or the cos ratio. So knowing that cos of the angle, which is 15, equals adjacent, which is 9 meters, over the hypotenuse, which is x. So isolating for x, we should get that x equals 9 over the cos of 15. Putting this in your calculator, we should get 9 over the cos of 15. We get 9.32 meters. 9.32 meters. And that's it. We've solved for x. Having solved both sides, we can now move on to solving the last angle, which is A. We have all three sides, 9 meters, 2.41 meters, and 9.32 meters. Now to solve this, we have to we can use any of these ratios. We can use sine, cos, or tan because we are given all three sides. Now remember this, in reference to the 15 degrees, 2.41 was our opposite side, and 9 meters was our adjacent side. However, since we're looking at a new angle, these all change. So the opposite side would have to be 9 meters, and the adjacent side would have to be 2.41 meters. So this is adjacent and this is opposite. And the hypotenuse stays exactly the same. So now let's use the sine ratio to solve this angle, because we've already used cos and we already demonstrated the use of tan. So sine of A equals opposite, which is 9 meters, and the hypotenuse, which is 9.32 meters. And remember, to solve for A, we have to use sine inverse. So sine inverse of 9 over 9.32 should give us our angle. And that angle is exactly 75 degrees. So 75 degrees is A. And now we can check this if this is all right, because remember, in a triangle, the sum of all the angles have to equal 180, right? Because that is a rule of the triangle. So if we have done this right, 75 plus 15 plus 90 should equal 180, because that is what it has to equal to. And guess what? It equals exactly 180 degrees. So we know that we've done this correctly, and this is the right way of doing these procedures.